All right, now let's select invoices that are larger than all invoices of client 3. Once again, we want to simplify this problem. So first, let's get all the invoices of client 3. So in our SQL invoicing database, first I'm going to select everything from the invoices table where client ID equals to 3. Let's execute this query and make sure we get the right result. All right, so here are all the invoices of client 3. As you can see, each invoice has a total amount. Now look at invoice number 15. The total amount is $167. So this is the largest invoice of client 3. Now we want to change our query to get all invoices that have a total amount greater than $167. So first we want to change this query to select max of invoice total. Let's execute the query one more time. All right, now we get $167. Beautiful. So now we can use this query as a subquery to select all invoices with total amount greater than $167. So we want to select everything from the invoices table where invoice total is greater than, and this is where we use our subquery. So let me indent these 3 lines. That's better. Let's execute the query one more time. There you go. So these are the invoices that are larger than all invoices of client 3. Now there's another way to solve this problem using the all keyword. Let me show you. So I'm going to open up a new query window. So once again, we want to select invoices that are larger than all invoices of client 3. So we can convert this sentence to a query like this. Select everything from the invoices table where invoice total is greater than, then we write our subquery. Here we want to select the total amount for all invoices of client 3. So select invoice total from invoices where client ID equals to 3. However, when we run this query, instead of getting one value, we're going to get multiple values because client 3 has multiple invoices. Let's take a look. So there you go. These are the total amounts for all invoices of client 3. Now in this query, we want to select invoices that have a total amount greater than all these values. So we prefix our subquery with the keyword all. When we give this query to MySQL, first it will execute this subquery. This subquery returns a list of values like this. Let me just temporarily delete this and show you the amounts. Like $150, $130, $167, and so on, right? Then MySQL is going to look at the invoices table. For each row, it will compare the invoice total with these values. If the invoice total is greater than all these values, that row will be returned in the final result set. So this is how the all keyword works. Now I'm going to revert this back to what we had earlier. So here's what you need to take away. Sometimes your subqueries return a single value. Sometimes they return a list. Sometimes they return a table. In our first implementation, our subquery returned a single value. That was the max of invoice total for client number 3. When we execute this query, we get $167. So in our main query, we can compare invoice total with $167. In contrast, in the second implementation, our subquery returns a list of values. In this case, if we don't add the all keyword here, MySQL will not be able to compare invoice total with all these values. So that is why we'll have to prefix this subquery with the all keyword. So these 2 implementations are interchangeable. Wherever you have the all keyword, you can rewrite that query using the max aggregate function. In my opinion, both these queries are readable. Some developers prefer to use the max function. The others prefer to use the all keyword. In this particular case, I personally think this second implementation better aligns with the problem at hand. So I prefer this second implementation, but they're both equally good.